So I guess good evening. This is a presentation that's been sort of in the works for about a year. Had mentioned it in town meeting to have a sort of a summary on looking at solar for homes in town. A little bit of my background is, I sit in the Energy Committee professionally. I've been working on solar projects for close to 20 years. As part of my work, it's been the permitting, it's been some of the I call it the contract stuff that goes on back and forth. It's oversight of construction. It's all different aspects of large and small solar. A little bit of, I'll call it necessarily side work, but helping out a few people that have had some contracts from a variety of suppliers of solar systems, go through and point out some things that are good, some things that are bad. More interestingly is with the way the real estate market has been of the past 2 to 3 years, people are selling their houses that have solar systems that are tied into a long-term lease. And we'll talk about this in more detail, but the bottom line is reading these contracts is really important, and I'll get into some details later on in the talk. But this is something we meaning myself and the real estate agent, have sort of chuckled about. At the same time, it's a lot of money, and this is hopefully it will give you some information to make some good decisions. So, as I've entitled this, is photovoltaics. There are a lot of things you need to consider, but didn't know where to start. And believe me, I've had probably 6 discussions over the past year about this very topic, and this is kind of why we're presenting this and giving people the opportunity to ask questions. So, I go next slide. Oops. That's the beginning slide. Next one. So some of the fundamentals on how to understand, if you ever read your electric bill, these are some terms that are on here, and other terms are associated with putting a solar or a photovoltaic system in. 1 kilowatt is equal to 1,000 watts. That would be like if you're running 10 100-watt light bulbs for an hour. That would be 1 kilowatt. 1 kilowatt hour, would be running those bulbs for an hour. A megawatt is 1,000 watts, and typically the average home in the U.S. uses about 10 megawatt hours instead of 1 megawatt hour, so it kind of gives you an idea of the production you need. Some of the technical terms that usually are not well explained in some of these contracts that these providers present to people. Intertie connection, which is direct connection into the electrical grid. That's an approval process and an application that's done by the supplier and then the installer to get permission from the utility to install the small system. Distributed generation, this is what we are doing. We are, this is electricity being generated at a small scale. If you have an electric emergency generator, that's also considered distributed generation, but again, it's not continuous, whereas the solar is continuous. Net metering, that's a process it's a nationwide concept. However, some states in New England look at it slightly differently, but what you're doing is you're sending the power into the grid and receiving credit for the energy produced. In the case of Maine, a few years ago, they went from about 3 cents a kilowatt hour to current pricing. That was a change of leadership at the state level, and that was a major advancement to push solar for the systems in Maine. Renewable energy credits, or RECs. This is simply that green credit that you get. There is a market for that, and then can be sold. I have a system at my house, and even though it's small, I'll make a couple $100 a year, which is, it's not bad, but it adds up over 20 years. Currently, the state of Massachusetts has this thing called the SMART program. This is a tiered system that started about 4 years ago, and 5 years ago, and the utility will pay you for a period of 10 years based on the production of the system. There were several blocks. If you got to the first and second block, you got a higher rate, but as people get into the system and they move in down the block system, you'll be receiving less money for your RECs. For the SMART program payments, and this is in addition to the kilowatt watt-hour offset. So it's a fascinating program. This is one of three programs that the state of Massachusetts had. At one point, they did have what's called the SREC, and then they had the SREC 2, and now the SMART program. And the SREC 2 were simply based on a quarterly fee based on how much you produced, whereas the SMART program is based on monthly production, and then you receive a check 2 to 3 months after that's done. The meters that the utilities put in can record this, so that's how they track that. So next one. Basic components of a photovoltaic system. The PV module or photovoltaics, or the solar panel or solar cell, they convert sunlight into DC power. There are generally two types of panels that are commonly available: commercial and residential panels. The residential panels, which we'll concentrate here, that we'll concentrate on, typically have 60 to 140 cells, and they are the most common. Some of the commercial ones are 156 and higher, and the output in watts, which is critical to design the system, is between 380 to 500 watts, and that's a huge jump in the past 10 years. Usually you'd see panels no larger than 340 watts. Residential voltage, each panel will have 30 volts DC per panel. They're strung together, and that's how you generate the higher voltage that gets converted from DC into AC power. Amperage, which is important to know what that is, because some modifications may need to be done to your electrical system, but typically a panel has 8 to 10 amps per panel. I'm not really going to talk about off-grid and battery storage or backup systems because those are a different situation, but I do make reference because there are some programs that may be advantageous to you. And again, most panels do generate DC power. There are some that do create AC power, but they're not very common, and they are they're costly compared to the DC. Next slide. So the primary brains of the system is the inverter. There are two types: a string inverter, which is the top picture, and a microinverter, which is the lower one. And these are the most common that are used. There are other types of inverters that are hybrid inverters that, again, I'm not going to talk about because they're not commonly used. The string inverter implies that, yes, you're stringing the panels together, and they will generally create somewhere between 400 and 600 volts DC, and then they're brought into this inverter, and inverter converts it into AC power, usually 240 volts. There are in the case of like an application where you're running higher voltages than that, a transformer may be needed, but again, that's usually more in a commercial setting. Microinverters, there are one for each panel. The 240 volts is brought directly to the inverter, and the DC is converted to AC power at that point. Both have their own benefits in the system design, but the cost is slightly higher with microinverters simply because it's more hardware. And to give you an idea, the range of a microinverter could be anywhere from $130 to $250 a piece, and a string inverter somewhere in as low as $1,500 up to $8,000, just depending upon the output. What has been an interesting change in the industry is the past 3 to 4 years is when you have a large system, meaning 30 or 40 panels, simply having two smaller inverters seems to be the way people are going, because a single inverter is a single failure point, whereas if you do have a problem with one string or half of the system, at least the remaining part can stay running while the other part is being the troubleshooting is done. So these are some things to consider. Most residential units that you see installed are simply one inverter, but you can start seeing two. That's an option. And both backfeed into the main electrical panel of the house, and that's critical. You have to make sure that your electrical service can handle the amount of power being backfed, which is basically the amperage that I mentioned before. Next one. So inverter considerations, the maximum watt and DC voltage input, and amperage is also a consideration. Like I said, the amperage, will decide, if you have to upgrade your panel, and that's something that that's done on a case-by-case basis. Inverter efficiency, converting from DC to AC power, basically, if you're seeing a 15 to 20% drop from the DC power to the AC power, that's common, but at the same time, there's inverters that are now pushing 95 to 97% efficient, and that's something that's just the technology has changed. A lot of older inverters, even 5 or 6 years ago, had all kinds of other hardware inside, and now you're looking at systems that are, an inverter is 20, 30 pounds, and there's no transformer in it, which is unusual. It's all done by solid-state circuitry. Installation and location considerations. I mean, obviously, you want to have it accessible in a place that it can stay cool. Most do have internal fans to keep them to keep the units cool. This is the case of the string inverter again. And the size and weight. Obviously, the size is literally, it might be a foot by 18 inches by 3 or 4 inches thick for a small 3,000 watt inverter, and some of the bigger ones could be, they're 12,000 watts, could be 80, 90 pounds. And where you put that and how it's actually fastened to the wall is a consideration as well. And one thing that has really changed over the past 20 years is the warranties. Typically, they would say 5 years is about it. You want another 5 years, you pay for it. But some of the inverter manufacturers are making making them with 20-year warranties. And I guess time will tell, because most of those inverters have only been out for 3 to 5 years. So next one. So the inverters connect to the 240 service. You need a double pole breaker if you've been down and looked at your service panel. If you have a well, if you have your stove, air conditioning, there's several appliances that you may have that are running at 240 volts. That's what you need. It's highly recommended that the 200 amp service is required. 100 amp service is probably going to be insufficient, as most PV systems do backfeed 20 to 30 amps, and what will happen is that the breakers will get warm, and it's unfortunate that it's an unseen circumstance of having a PV system, but you may have to do an upgrade to the panel. And I can give you one quick brief story. A gentleman I used to work with, who lives in Bellingham, just had a system put on. He had a 200 amp service, and because he also had an electric car charger in there, his system was maxed out. So as part of the work to put on, he had to rebuild the entire electrical panel, and it can now handle it, and the utility company did have to bring in and upgrade the service as well. So sometimes this happens, and sometimes it's not necessary. But again, this is something that you should be thinking about, and hopefully that if you're talking with a vendor that's going to be putting a system in, they should really be cognizant of that could be a problem. If you do battery storage, the battery storage simply just consists of another charge controller, the battery bank, and inverter that matches the battery storage voltage, and most common seem to be 12 to 48 volts. And again, 12-volt battery versus a 48-volt battery, you're looking at size, so size considerations, setbacks, and the various electrical code. I'll call it spacing away from combustible things and getting access to it is a problem. And sometimes, you just don't have the room and you can't do it. And just so you know, battery storage usually will add additional $20,000 to $30,000 onto the system. So next one. So the balance of the system, this is everything after you get the inverter and the panels, the racking, which is to hold the panels on the roof, conduit, AC and DC disconnects, utility disconnect, rapid shutdown hardware, signage, production meter, and an internet connection. Racking typically is on the roof. In the case of the town of Norfolk, if you were to put a system on the ground, that would require zoning board approval and review, and as much as the setbacks would have to be discussed as to where you're going to have it. And again, it's it's something that, that you have to consider. It's easier to maintain a system on the ground, but at the same time, the roof, a roof-mounted system is pretty straightforward. You can put it on as long as it meets the structure. If you are at a point where your roof is 5 years old or older, you might want to think about getting a new roof. And part of the reason why is that the solar panels, because they do get warm, you do get some decaying of the roof material. And in a perfect world, my recommendation would be to consider a metal roof for that area, whether it's a standing metal edge seam or possibly some of these metal shingles that, and there's several companies that do make fasteners to the roof that will adapt to the different types of metal roofs. So it's not a case of like in a conventional asphalt shingle roof, you're finding where the rafter is, you're drilling a hole in there, you're caulking it, putting in the anchor point, and then putting what's called the foot, and then flashing that, and then caulking that. So there's a lot less work to be done with a metal roof, but again, the cost is there. And then other considerations are snow shedding off the roof. A 10-12 pitch or a 12-12 pitch is 45 degrees. When you get snow will catch onto it, and when it goes, believe me, it will shake a house. And I can speak from experience from my experiences up north, where 2 feet of snow coming off the roof is a little disconcerting the first time it happens. One word of caution, and this is something that I found out after reading quite a few of these contracts from the various providers, is that obviously an internet connection is needed to maintain and watch the system. But again, it may not be secure if you're going with a third-party provider, and that could be a problem. So obviously that's something, that's the small minor details that are in the contract that you probably need to look at really closely and see how they're going to protect you. Sometimes they will have a separate firewall. Sometimes they will see if they can connect to your system, but typically they try to keep your system separate from their internet connection. Next one. So other things to consider: shading. Panels should have a clear southern to southwest exposure. The age of the house. Roof structure is a concern. Roof rafters that are 24 inches on center, and that's typically a house before the 1940s. You may find that, and the rafters could be undersized, and that's something that, from experience of projects that I've worked on, where these are large municipal buildings where they've tried to adapt a system to a 24 inches on center, and these are fairly substantial roof rafters. Bottom line is they just couldn't handle it, and the cost to I'll say marry up additional rafters or possibly putting in bracing became next to impossible. In one instance, it was in Framingham, where the biggest piece of wood you could get up into this crawl space was 5 feet long, and it just wouldn't work. It just was not practical. So. The current code for this area, the wind rating has to resist 130 miles an hour. For the most part, that can be determined by a couple things, and usually the racking manufacturer will tell you that if you're having you can only put in a 3-inch lag bolt into the roof. You'd space the anchor points, every other rafter, versus if you're going with 7 inches into the rafter, you could go with every third rafter to put an anchor point. And again, that's something that's something to consider, because every single hole they put in the roof is a point of that it could leak, and the less holes, the better, if you know what I mean. And then the other thing too is the house prone to energy surges? Surge protection, lightning arresters are necessary on the PV system, but surge arresters, would be needed for the whole house as well, because the sensitivity of the inverters, they're not, they can deal with, I'll call it fluctuations, but like a major surge, like 10, 20, 30 volts, it could shut the system down, and then you'd have to reset it, and that's something that you need to be aware of. Next one. So where to start? I'm a firm believer in energy conservation before solar, and this is what I did with my house, where you looked at LEDs, replacement of old appliances. There's a lot of rebates, mass save. We'll give you free LEDs. Eversource periodically will pay you $75 to get rid of your old freezer, and then they'll also give you a rebate of, it could be anywhere from $50 to $100 for a new refrigerator. And I know a new refrigerator or freezer is probably close to $1,000 now, but every little bit helps. But when you look at the actual operating costs, in my case, our upright freezer, which is now, I think, about 7 years old, was it reduced our electric bill simply by changing out by about $30 a month. And that was a big surprise to me. I never expected it to be that much. And, at that rate, we paid $700 for the freezer. I mean, it was in less than 20 months with the rebate, it was paid for. Air sealing and insulation, loss of heat is something that Mass Save can also do. They'll do a study on your home, and I recommend that. Energy trends, use trends, or behavior modification, and this is basically the simple, I guess, a complex way of saying, if you leave a room, turn off a light. And sometimes, you find out that you just leave lights on all the time, and this is something that you can easily save some money simply by turning the lights off. A deep energy retrofit. Again, these are programs that are funded. It can be funded by some Mass Save. Windows, garage, insulation, doors, larger projects, new insulation in your attic. In some cases, they're providing 75%. In some cases, it could be more. It just depends what the project is. And honestly, you can easily save 10% of your bill simply at no cost or low cost and a little bit of effort. So that's where I've started, and that's usually what I recommend to people. And once you kind of get that whole scenario under wraps, and you've got a good handle on that, and then we can go to the next slide. When it's time to look at PV. There are several options, but get more than one quote. And I'm not going to name names, and I'm not going to name companies of things that I've reviewed for people, but the language, and to give you an idea, the average contract is anywhere between 20 to 40 pages long, and this is something that you really have to read carefully, and you have to ask the questions. And I'm going to call it I'll be professional about this. Basically, it's the BS test. There's stuff in some of these contracts that make absolutely no sense, and I encourage you to ask questions if that's where you are. If you're already having someone do solar, you might want to just read again and just go ask some questions again about what this really means, because this is a big step for a lot of people, and I understand that, but at the same time, you don't want to get taken, and that's something that I've told a couple people, just walk away from it. It's just not worth it. And the reason why is the cost of the system, the monthly cost. It just doesn't make sense financially. So there is the direct ownership of the system has its financial benefits. I'll get to that in a little bit. That's where you physically own the system and you own everything. There are some downsides, but there are also some plus sides as well. The third-party ownership is also known as a PPA, or power purchase agreement. And other options that are available in Norfolk are community solar. There's a large field that's built somewhere in the state or within the Eversource territory, and you buy shares. And whether you buy 60 panels or 20 panels worth of electricity, and what you do is you get a credit, and obviously you pay them. You pay that developer for his portion of the electricity that applies to the shares that you bought. And I know a few people in town that do have that, and they're very happy with it. But again, this is because they already did the analysis of their home. They can't put solar on the house. They don't have setbacks for ground mounted, and they also don't want to cut down a lot of trees either. So this is an option too. There are options of third party power suppliers such as Constellation, Inspire, Enernoc, Public Power that provide green power. But if you've ever gotten one of the mailings from them, you'll notice that the price is usually set for 6 months, and then after 6 months it just goes up and up and up, and it just becomes a little bit of a it's a cost thing that it's probably not the best option for some people unless you stay on top of it, because if you cancel and then go with someone else, I think you want to try to do the easiest thing, and this is something that I've looked at, and I just don't recommend it. And I mean, I'm more than happy to talk. If anybody's got questions, we can talk about that later, but offline as well. But and then municipal aggregation. The town is looking at municipal aggregation with Colonial Power, and we're just in the beginning of this. The contract to begin the investigation was signed recently, and this is something where the entire town actually uses the buying power of Colonial Power to purchase a set amount of power at a discounted price, and whether it's 4 cents, 2 cents, 8 cents off the kilowatt hour of electricity only. In some cases, that can add up. But if your electric bill is $500 or $600 a month, that can add up as well. So we're still in the exploration point of this, and I can tell you we'll try and keep everybody up to date as things go on. I know there's a meeting coming up in the near future with the selectmen, and we'll go from there. Next one. So the benefits of direct ownership. If you own everything, if you own all the equipment, it's a 1-for-1 kilowatt credit. It's both the kilowatt, the electricity, and the transmission charges. So for every kilowatt you generate, it's 100% offset on your bill. The net metering process allows you to bank excess power, and credits are carried over month to month to month. I work with a woman now who has had a system on her house for 4 years, and they're now carrying somewhere between, as she said, $1,200 to $1,500 a month. And it's nice because you always have that there. And if you just happen to be running the air conditioner a lot during the summertime, she says, you tap into that. And there's options where you can get a payout from Eversource or the electric company. She's actually in National Grid territory, where they had the option of getting a check every 6 months if they were running a credit, and they're choosing just to leave it there, and it works for them. You get 30% tax credit on your federal income taxes, and $1,000 tax credit off the state income taxes. I know it's not much, and just so you know that this is only for Massachusetts. It's only a one-time credit. So if you were to add to the system later on, you can't. You can't take another tax credit. There are no personal property tax increases for that improvement, such as like if you put an addition on the house, you'd be taxed for it. But it's a 20-year exemption, and the reason why 20 years is chosen is because at the end of 20 years, the equipment is more or less obsolete, and there really is no value. So. The SMART program, which I mentioned previously before, these are direct payments for the utility for the amount of power you produce, and this can add up pretty quickly. If you have a big system that's generating a lot of power, you could see a couple $1,000s a month potentially, and it's an interesting program. But again, as I mentioned, if you're like in the fourth or fifth or sixth block of the funding, it's a lot less than the blocks 1 and 2 and 3. So that's something to think about. But again, the program is now into 5 years, and will be ending shortly. What's going to come after that? I have no idea. An interesting aspect of battery storage with the solar system is you can enroll in this program called demand response, and what it is that you enroll your system, you will get a call from the electric company, and they'll ask you to basically shut the system off, or shut the power off to your house. So that goes to the main breaker, and you run off your batteries. And what this does, it alleviates the peak demand on the grid. And I can speak from experience. At the prisons, they used to do this, and it was fairly lucrative for a 4-hour shutdown. Even though they're using an emergency generator, they're not using battery storage, but it's something that it's definitely fairly lucrative. And if it happens once or twice a year, you could see a couple $1,000s maximum. So next one. So the downsides to direct ownership: potential repairs, non-warranty claims. So that means if a panel, breaks, it gets hit by something, tree branch. It's common to see what are called thermal breakage, and usually it doesn't necessarily affect the output of the panel, but it does cause the system to quickly drop in efficiency, but you're on your own unless you set up a contract with the installer to handle this, and it's either an annual payment or time and materials billing. And these contracts are becoming more and more common. 10 years ago, wasn't even heard of because people thought you could just put the systems in and they'd be perfectly fine. Well, they're realizing that that's not the case. The warranty claims, does a third party handle them for the installer, and it's usually a limited time frame of 10 years. So what happens after 10 years if the system's supposed to have a life of 20 years? So from years 10 to year 20, you're going to have to find someone or work out in the contracting aspect of the project that you want them to be able to provide support for the entire life of the project. Power production guarantees do not exist if you own your system. In the case of if it's a power purchase agreement, the companies will actually oversize the system to make sure that you're meeting their production. So that could mean an extra 3 to 5 panels or 10 panels, depending upon what the array size is going to be and the direction facing south. So that's something that you want to look at. And is it a really big deal? Probably not, but again, some people, they don't want to pay an electric bill, and that's something that the power production guarantees do. If they miss the targets, whether it's weather or breakage or downtime, then you get a check from these companies, and so this is something to consider. You have to take on some tasks monitoring the system. If you have a windstorm, go up and look at go from the ground, get a pair of binoculars and look at the system, and this is something that you really need to. You take ownership on, and it's actually kind of, it's nerdy, but it's also kind of fascinating too, because you get to see how the system performs, year after year after year, and that's with mine here in Norfolk. Yes, I've been on the roof a couple of times shoveling it off in the sun in the wintertime. It's interesting to see, how much snow really affects some of these some of the production rates. But again, these are things to consider. So tax liabilities. This is kind of a new thing that's been coming out of Washington, where the thinking is by a political party that the revenue that comes from the SMART program or from RECs should be taxable income, and it should be taxable. And what they're thinking is that this will actually pay for any incentives and any tax credits that that you're getting as part of putting the system in. So nothing has ever moved forward, but it seems to be a very one-sided issue, and this is something that may or not become an issue sooner than later. I just have no idea, but it always seems to take a life of its own on during tax season, and the various emails and various websites that I've looked at. So next one. So the power purchase agreement, the system is owned by a third party. They are fully responsible for everything there. The downside of what they do is they usually will use an older component. Meaning by that is, if you remember the first couple of slides where we talked about the size of the panels, they will use a panel that's between 320, 340, 350 watts, when the standard right now is between 400 to 500 watts. And what that means is that there's more panels on your roof, there's more mounting holes, and why they do that is because they bought all these panels in anticipation of all these systems that would be going in. What they didn't anticipate was the little bit of the downturn in the market. COVID really screwed things up for everybody too. But at the same time, this is something that if you're getting an offer or in a proposal from a company saying they're going to put 320 watt panels on there, saying, look, you want something much more current. They still make 320 watt panels, but it's more for replacements than anything else. As I mentioned, the power purchase agreements oversize the system to meet power production guarantees. So this is, again, you're looking at more panels on your roof and more holes. And believe me, I'm a firm believer the less holes you have in your roof, the better. You can sign a contract for 20 to 30 years. The 30 years is something that's becoming more and more common, and I don't know anybody that's nowadays that would be staying in a house for 30 years. Yes, we've lived in Norfolk for more than 30 years, but again, a 30 year that's a long time. what your monthly payment is, you pay them monthly for the system equipment and or electricity. It's a combination of both or one or the other, but you're not paying the transmission costs for the power coming in. And so you're essentially still going to get a smaller bill from the electric company, but it's still not going to be the same as it was if you were paying for both electric and transmission and transition charges. So your monthly fee does cover the equipment costs, the installation, any potential warranty claims, and the permits and paperwork with the utility. The paperwork with the utility, is realistically 10 to 15 hours per location. It's really not that much. What they're banking on is they're hoping that the equipment doesn't fail, because the time and effort to remove old equipment or broken equipment and put new equipment on, that's what they're hoping they can limit their liability on. So, next slide. So the power purchase agreements, you really need to read the fine print. One of the most interesting things I've seen of late is the contract buyout terms. If you sell the house, there was one that I was surprised to see, that the terms required a full payment of the lease payments. So this family was 12 years into their power purchase agreement, and they were expected to come up with the last 8 years of the payments at once. And I don't know how it was resolved, but that just was that. I just couldn't believe that someone signed that, because it wasn't clearly spelled out in the contract. But that's what they had their little closeout table and transfer of assets from one owner to the other, and that's what the payment was. Some will allow the transfer of the system in terms, but require payment of administrative costs, and that still could be $2,000 to $3,000. So these are something to think about. And you may have remembered a couple years ago that there were people that were complaining because when they were trying to sell their house, the registry of deeds had a lien on their house. That's been kind of squared away, and people understand that, yes, the lien is because you have solar system on your house. At the same time, people I think just sort of say, okay, we'll just get it on there and we'll worry about that later, and then it becomes a problem. So these are all the things you need to manage. What you're signing, what the impacts are. Does this delay, if you were to sell the house and you were forced to sell it because of a job relocation in a matter of a week or 2 or 3, that's probably not going to be realistic. But if you were, say, a 2 or 3 months down the road, you're trying to sell the house and then realize that the lien is going to be stalling things. This is something you want to understand what the impacts would be before you sign the contract. So the response time, if there's a problem, what does the contract say? And I can assure you that most of these companies do not fulfill that contract, and I'm saying that with knowledge of at least half a dozen small systems that they call saying, look, I think there's an inverter that's out, or I think there's a problem with this, and all of a sudden they say, okay, we'll call you back, and 3 weeks later, nothing, a month later, nothing, and then you call again, you just kind of get the runaround because they're too busy. So this is something that you want to have that locked in, that yes, if you call, they call you back in 48 hours and they have someone there within a week or so, and I think that's pretty reasonable. Bottom line is, do the numbers make sense? And I will give you a quick summary of an actual contract. We have some friends in Medfield, and they were going to put solar on their house, and they were going to sign, the contract was for 30 years, and their total payments for that system was $81,000. Looking at what they had for equipment, and they gave a very detailed explanation, I could personally purchase that equipment for $31,000, and with the installation costs of maybe $10,000 or $12,000, you're still under $45,000. So what's the other $35,000 to get you over $80,000? This is something that I kind of view this as like if you go to a car dealership, it's like they'll say, what can you afford for a monthly payment? And you say $400, and it's like, well, that's great, because then they stretch it out to 7 years and you're paying a ton more in interest. But this is something you need to be very, very careful of, because it doesn't make sense to purchase something that, or basically get into a contract that you're basically paying twice what the system would cost if you were able to pay for it yourself. And there are loans that are out there. There are programs that banks provide for low interest loans to put solar systems on. And with some of the new federal programs coming in, it's something that will change the landscape of how these contracts are put together. But for right now, people know that cost of electricity is going up, so they're going to, these vendors are going to take advantage of that situation that people are desperate and they want to try and save some money. So, next slide. So the tax implications of the power purchase agreement. If you were the owner, you're not, but the owner of the equipment gets a tax benefit at the state and federal level. So for a system worth $50,000, it's $1,000 for Massachusetts and $15,000 for the Fed. The owner, again, gets payments from the SMART program, and this could be in the range of $400 to $1,200 a month based on the production of a 1,900-watt system. These are actual numbers. There's a small project I worked on down in Wareham where we put it was a 19,200 watt system, and because we got into the second tier of the SMART program, this particular location, they were seeing credits on their bills of $400 to $1,200 a month. The summertime were much higher than the wintertime, but those are realistic, and that's real money. And when you start adding, even if you took $1,000 a month, that'd be $12,000 a year, and you get to $50,000 pretty quick. So, but unfortunately, like I said, the tiered system is such that the payments would probably be maybe probably half or maybe 2/3 of this. Next one. So backup power or off-grid applications. Just to mention, the ability, if you have a PV system on your roof, or you're using it, for just to backfeed into the system, to utilize it such that you're charging a battery bank, it's a lot more equipment than you would normally need. But the battery bank for storage, you're making AC power from that when you need it. You probably would need a transfer switch or other switchgear that sense power outages. All of this will probably, if you're looking at a $50,000 system, you'd probably be adding another $25,000, probably another 50% of the system. So this is something to consider. But again, if you're looking at the potential of demand response, or keeping your power up and not using a generator, that's some people want to do that, and again, that's a personal choice. So next one. I know we have 2 people on the line. Any questions for you guys at all? No questions? Okay. Well, hearing no questions.
I have a question.
Okay. Oh.
Can you go back to the slide about saving, was it 30% federal taxes?
Yep.
And
Yeah.
10% state? Is that per year, or is that a one-time?
No, it's a one-time. That's a one-time. Yeah, we have our one person in the audience here was asking a tax question. I don't know if everybody heard that. They were asking if the 30% tax credit is annually. It's not. It's just a one-time thing. So, but again, in Massachusetts, if you were to add to the system, you can't take another $1,000 credit. But if you were to add or make a substantial change on a system at the federal level, you can take a portion of that cost. It wouldn't necessarily be 30% unless it's brand new equipment that's completely separate from the other equipment. So. Okay, well, if no one's got some questions, I think we can call it a wrap and call it a night. We can maybe get home and see a little more football on Amazon and go from there. So, Kate, are you all set with anything, or you got questions, or?
I'm all set. I will just note that we will be putting this recording up on the website. I'll be up either tomorrow or Monday morning.
Okay. And again, if anybody has, if the two folks that are on the line, if you've got questions, you can, if you go to the link on the town website, my email is there, so you can always ask some questions, and I can give you more dirt and more information that may or may not help you. But again, I know this is a big decision for some people, and it should be a big decision because it's a big investment in the house. I mean, if you think about $50,000, that's basically, that's a substantial kitchen remodel. So, but okay. Well, thank you, everybody. I appreciate it. Have a good night, and like I said, if you have questions, just send an email. Thanks.